What's going on, everybody? Welcome back to the channel. We have this interesting question that says that find the square root of 3 minus the square root of 8. Well, I'm going to be using two methods to solve this question, and you choose which method is better. So let's start with the first method. So we'll call this method 1. For method 1, we have the square root of 3. 3 is same as 2 plus 1. Good. Minus, we have the square root of 8. 8 is same as 4 times 2. Very good. So this becomes the square root of 2 plus 1. So 2 plus 1, which is 3, minus. Now applying the property of radical, we're going to be separating this to become the square root of 4 times the square root of 2. And then simplifying further, we have the square root of 2 plus 1 minus the square root of 4 is 2, and when multiplied by 2, and when multiplied by the square root of 2, we have 2 root 2. Good. So simplifying what we have inside of this bigger radical, this becomes the square root of, now 2 is same as the square root of 2 raised to power 2. The same thing. Plus 1. 1 is same as 1 squared. Now let me extend this a little. Now we have minus 2 root 2. Now 2 root 2 times 1 will give the same thing, 2 root 2 here. So why did I write it this way? It is because now what I have inside of this bigger radical now looks like a famous identity, which is a squared plus b squared minus 2ab, which is equal to a minus b all squared, which is a perfect square. And if we have to compare, you notice that our a is the square root of 2, our b is 1, and then this is this 2 here. Our a is the square root of 2, and then our b is 1. Now we're going to be writing what we have inside of this bigger radical in this form. So this becomes the square root of, now we have a minus b. What is our a? A is the square root of 2 minus b. B is 1. Very good. Raised to power 2. Now notice that this square root and this square cancels out, leaving behind the square root of 2 minus 1 as our final answer. So that is our first method. For our second method, let's call this method 2. For method 2, we have the square root of, I'm going to be leaving this 3 like that, so 3 minus. Now from our simplification of the square root of 8, we got 2 root 2. Now we're going to be expressing what we have inside of this parenthesis as a perfect square. And there is an identity for that. The identity which says the square root of a minus, because of this minus here, the square root of b all raised to power 2 is given as a plus b minus 2 root ab. Very good. Now let's use this identity to compare what we have here. Now our a plus b, so a plus b is equal to this 3, and then our ab by comparison is equal to this 2 here, so ab is equal to 2. You notice that we have a sum of roots if we consider a and b as a root of a quadratic equation. So we have sum of roots, which is equal to 3, and we have product of roots, which is equal to 2. So let's say or assume that a and b are roots of this quadratic equation, which is x squared minus sum of roots, which is a plus b times x, plus product of roots, which is ab, equal to 0. Now substituting, we have x squared minus sum of roots, that is 3, times x, plus product of roots, which is ab, that is 2. So I'm going to be putting 2 here, equal to 0. Now we can factorize this quadratic equation. So I'll multiply 2 parentheses and equate them to 0. Now to get this x squared, that means I'll multiply 1x here from the first parenthesis by the other x on the other parenthesis. Now, what are the factors of 2 that satisfy this equation? So we have 2 here. The factors that I'm going to be using will be negative 2 times negative 1, because their multiplication gives positive 2 and their addition, which is negative 2 plus negative 1, gives negative 3. But let's put them here inside of these parentheses. So we have minus 2 minus 1. Very good. So there are 2 cases here. We have x minus 2 to be equal to 0, or we have x minus 1 to be equal to 0. For the first case, the value of x will be, moving negative 2 to the right, we have 2. For the second case, the value of x will be, moving negative 1 to the right, we have 1. Now let's come back to this identity. Well, whatever we have here must be positive. And for this to be positive, the square root of a must be bigger than the square root of b. That means the value of a must be bigger than b. So we're going to say that a from here is the bigger value, that is 2, and b is the smaller value, that is 1. Now let's put them back here. So we have here to be the square root of a is 2, minus the square root of b, that is the square root of 1, all raised to the power of 2. And this simplifies into the square root of 2 minus the square root of 1 is 1, all raised to the power of 2. Very good. Like I said, this is the perfect square to what we have here. So I'm going to be replacing this with this. So let me remove this and replace this with this. So I'm going to be writing the square root of 2 minus 1 all raised to power 2. This is equal to, now see that this square root cancels out the square, leaving our final answer to be the square root of 2 minus 1. And there you have it. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.